Welcome to this Reigate College Maths Year 2 Core Pure video covering higher derivatives of functions. This is not really strictly part of the series, but we're going to use what we see here when we look at Maclaurin series. There isn't really anything new. It's really just using the rules that you've learnt in the Year 2 Pure Maths as part of the Single Maths syllabus. In particular, the chain rule and the product rule will be important. And we're going to be using those to find higher derivatives, second derivative, third derivative, fourth derivative, fifth derivative even. So let's look at a couple of examples, then you should do some practice, and then we will be using those later on, and you can follow on with the next video on Maclaurin series. So let's switch to the visualizer as we usually do to look at examples. Here we go. So our first example here says that we've got a function y equals ln of 1 minus x, and we want to find the value of the third derivative, and actually we're going to find the value at a particular point, particular value of x equals a half. So we're going to differentiate this. So we're going to say dy by dx is equal to, well, when we differentiate this, we've got to use the chain rule. Differentiate the ln, we get 1 over 1 minus x, and then we've got to multiply by the derivative of the inner function, which is minus 1. So we get minus 1 minus x, the power of minus 1. I'm going to write it like that rather than minus 1 over 1 minus x. Because we want to differentiate this again. So the second derivative, d2y by dx squared. Again, we can use the chain rule on this. So when we differentiate this, we're going to reduce the power. So we're going to get the minus 1 times the minus. So we're not going to have a minus there. 1 minus x, the power of minus 2, times differentiate what's inside, which is minus 1. So we're going to get our minus sign back. So we get minus 1 minus x to the power of minus 2. So again, chain rule, d3y by dx cubed. The third derivative is going to be, well, we're going to bring that minus 2 down here, times the minus is going to give us a 2, times 1 minus x to the minus 3. And again, we're going to get times the derivative of what's inside, minus 1. So we are going to get our minus back again. And then we want the value of the 3y by dx cubed at x equals a half. So we're going to say at x equals a half. And then sometimes we write this like this, d3y by dx cubed. And then you have a bar at x equals a half down at the bottom of that is equal to minus 2 times 1 minus a half is a half, the power of minus 3. Which is minus 2 times a half to the power of 3 would be 1 over 8. So this is 1 over 8 to the power of minus 1, which is 8. So it's times 8, which is negative 16. Okay, so there's an example where we have used the chain rule a series of times. If we look at the next page in the course workbook, we've got an example here where it says that our function f of x is e to the power of x cubed. So show that f dashed of x, the derivative is a x squared times f of x, where a is a constant to be found. And then we're going to differentiate twice more and show that the next two derivatives can be put in this form. And we're going to find the values where x equals 0. So for part A, we've again got a function within a function, so we're going to use the chain rule. So f dashed of x is equal to differentiate the outer function, so that's going to give us the same thing, e to the x cubed, times differentiate the inner function, the x cubed, gives us 3x squared. So this is equal to 3x squared e to the x cubed. In other words, that is 3x squared times f of x. So the constant a they've given us here is 3. So a equals 3. Part B. B part 1, that is, f double dashed of x. Well, we've got to differentiate this now. Double dashed of x. Well, now we've got to use the product rule. So the first part of my product is going to be 3x squared. So I'm going to say I'm going to differentiate that. So that's going to be 6x times e to the x cubed, plus then we've got 3x squared times the derivative of e to the x cubed. Well, the derivative of e to the x cubed is just this whole thing, isn't it? So 3x squared e to the x cubed. So this is equal to, well, the question asks us to put it in terms of f of x and f dashed of x. That's 6x times f of x plus 3x squared f dashed of x. Second part, f double dashed of x is equal to, well, now we need to use the product rule on both of these parts here. So the first one, and again we want it in terms of f dashed of x, f of x, and f double dashed of x. Sorry, this should be triple dashed here. There we are, third derivative. So differentiate this, that's going to be 6 times, leave that alone, f of x, plus, leave that alone, 6x f dashed of x, plus, differentiate this is going to be 6x f dashed of x plus 3x squared times, if we differentiate f dashed of x, we get f double dashed of x. Putting these two together, we've then got 6 f of x plus 12x f dashed of x plus 3x squared f double dashed of x. Now in this case, what I've done is I've gone from here, this notation with f of x and f dashed of x in, so we don't necessarily need to have our function explicit, so just in terms of x, in order to be able to differentiate it. Okay, so we've shown what we needed to show for B, parts I and II. Let's go on to part C. Deduce the values of f dashed of 0, f double dashed of 0, and f triple dashed of 0. Well, let's start off with f of 0. F of 0 is going to be e to the 0 cubed, which is e to the 0, which is 1. So f dashed of 0 is going to be, well, it's going to be 3 times 0 times f of 0. Well, that's just 0. Anything times 0. F double dashed of 0 is going to be, again, if we substitute in here, we're going to get 6 times 0 times 1 plus 3 times 0 times 1. So that's also 0. F triple dashed of 0 is going to be 6 times f of 0. So 6 plus 0 plus 0 is 6. So those values, 1, 0, 0, and 6. Oops. It might seem a little bit trivial substituting in 0 to these functions, but that will become important, and we'll see that in the next video when we go on to look at Maclaurin series. But I'm going to finish here and do that in a separate video. So thank you for listening, and we'll be back in the next one on Maclaurin series.